All right, so we're doing midterm practice day number 2. Remember, today is a day where we're going to get to number 12, and then I'm going to have a horizontal line to show you like this is the end of the day 1 content. Okay, so up to number 12 is all day 1. Once we start 13 and on, that's day 2. So that's Friday's test, okay? So we're still working on Thursday's test. So there's this question right here, graph the following. So let me make a coordinate plane here, and then I want to remind you guys of the formula. Whoops. Sorry about that. Let me try that again. All right, now the formula for doing these looks like this. F of x is equal to a over x minus h plus k. Now, your hk, that's going to be where you draw your asymptotes. Those are the horizontal, vertical lines you cannot touch. Okay, both. The horizontal and the vertical line you cannot touch. That's where you're going to do it. And then a positive A results in a graph that looks like this. And if A is negative, it results in a graph that looks like this. Bless you. So it's like two little pieces. Okay, these are called inverse functions or reciprocal functions, but sometimes they'll call them rational functions, but it just depends. Okay, so let me kind of help out a little bit with these pictures. So it's going to look either like this or like that. Okay, so in our problem here, let me just create my markings for this graph. So I'm just going to label a couple things. I want to figure out my HK. So what is my HK for this problem right here? Negative 1 what? Negative 2. All right. Good. So I'm going to go to negative 1, negative 2. I'm going to put a dot right there. Remember, you're not supposed to see the dot, so make it really tiny. And then you're going to draw horizontal and vertical dashed lines through it. So like this. These are the lines you're not supposed to touch. Okay? And then once you do that, you just ask yourself, well, what is A? Is A positive or is A negative? So A is 2, right? That number on the top, it's a positive 2. So A is positive, which means my graph is going to look like this. Here and there. If it was negative, you flip it. The one on the bottom left is going to go to the top left, and then the big one on the top right will go to the bottom right. Okay? Remember, you ignore the black coordinate plane. Once you create your new focus, those red lines, that's where you're focusing now, right? That becomes your new coordinate plane, then that's where you draw. But that's all you're going to have to do. You're going to choose the right picture when it comes to the quizzes, all right? You're not going to have to draw it. You're just going to have to be able to identify it. Okay, so remember your HK tells you where it's located, the little horizontal and vertical asymptotes, and then your A value tells you whether you draw it on the bottom left and the top right, or you flip it upside down and you do top left, bottom right. Okay, so are we okay with this one? So notice this equation for rational expressions, the absolute value, the quadratic, which is the one that we just did right now, the square roots, they're all the same. Same h, k, and all that stuff, right? They're all related, it just kind of looks a little different. So, any questions on this one? Because I think this might be the hardest one of the day, I think. We'll see. I'll give you a little bit of time. I'm going to pause this so you guys can write this out. Okay, so for number 9, working alone, it takes Jake 6 hours to dig a 10-foot by 10-foot hole. Mary can dig the same hole in 5 hours. How long would it take them to dig the hole together? So the formula we're going to be using is this one right here. t equals to xy over x plus y. Okay, we need to figure out the value of t, but they gave us x and y, even though they didn't like specifically say it. But I'm going to say that Jake is going to be the 6 hours, and Mary is going to be the 5 hours. So I'll call that x and y. So t is equal to 6 times 5 over 6 plus 5. So it's 30 divided by 11, which is, well, I think I'll leave it like that, 30 over 11. Now, they might want a decimal, so let me just tell you what the decimal answer would be. Give me a second, I'm just calculating this. 2.72, so approximately 2.72 hours. Now, again, guys, when you guys are writing this out on quizzes, you don't have to put hours, okay? Just put 2.72. They'll tell you what number to round it to. So they just want 2 numbers after the decimal, then you can leave it like this, or round it up if you're supposed to, okay? Now, if they told you how long it takes one person to do it, and together, that means you would have plugged the number into t, maybe one into x, and all you got to do is solve for y using the same equation. Okay, so there's no 2 equations. One equation can solve both types of problems. It just depends on what they gave you. Okay, and if you, I'm sure we have a working together section. I can't remember when we did it, but let me check chapter 5. There it is, 510, working together. So this is the ones that look, the ones that they tell you like together 16 days, one person did it in 20. Notice how we plugged in the information, we cross multiplied, and then just solved. Those are a little bit harder, the ones that you have to solve for one person, because there's more work. But it's not a different equation, same thing. Okay? So let me get back to this one right here. So that's number 9. Number 10. Now you guys can just type this into your calculator, okay? But if you didn't have a calculator, you are going to have to think of 2 numbers that multiply to 63, and they are going to have a square root, at least one of them. So give me 2 numbers that multiply to 63. One of them has to have a square root.
9 and 7.
All right, 9 and 7, and the square root of 9 is 3. And, oops, I put the wrong number right there, 7. And I'm done, that's it. Now, if you punch that into your calculator, it'll do the same thing, 3 radical 7. So, just plug it in. No, I just remembered right now. So, simplifying this next piece right here. 45 n to the third y squared. Now, remember, my index here is a 2. Okay? My index here is a 2. So, I need to make sure that the powers match the index, but then I also need to take out that 45. Okay, so let me break it up into numbers first. 9 times 5, n squared n, y squared. Now remember, the reason why I put them as squares is because the index is going to match the powers. Okay, so once I have that, I can take the 9 out. That's going to become a 3. So that's 3. And then the n and the y, the ones that have squares, those are going to go outside. And then what's left inside will be a 5 and an n, and that'll be your answer. Now remember, your calculator can do the square root of 45. If you punch that in, it'll give you 3 radical 5. So notice you'll have 3 radical 5, but your job is going to be to figure out the letters. Okay, how many letters come out? Right, so that's going to be a little tougher. Not a lot, but it is different. Okay, so remember, look for your index. If this was a cubed root, then the n would go out, but the y squared can't. There's not enough of it. Right, so it just depends on what the root is on it, what the index is. So that's number 11. This is the last problem from day 1, right here. Okay, last problem from day 1. After that, it's day 2. So if you're building a note sheet for yourself, then your first page of note sheet should be based on the first 12 problems. People have asked me, can I just use these 12 problems that you gave us on my notes? Yes, you can. Use whatever you feel is going to be helpful without it being cheating. In other words, like you can't be using a computer or your phone, but you can include anything you want in your notes. For the first day and the second day, you can create 2 different sheets if you want. I would if I were you. First day would be the first 12 problems. I'd probably write them all down, make sure they fit. And then any extra space you might have, put in some formulas, things like that. Maybe some squares, right? Like 1, 4, 9, 16, 25. Those are square, they have square roots. Maybe some cubed roots, right? So for us, the cube roots would be for 1, 8, 27, 64, and 125, right? So remember those, okay? Write those down in your notes somewhere. So, all right, cube root of negative 16x to the 5th y cubed. Now, if you guys remember, I told you the first thing you should do if you have a cubed root that's negative is just take it out. Take out the negative, because it's supposed to go back outside. Thank you. Now, 16 does not have a cubed root, but I know that 8 times 2 is 16, and 8 does have a cubed root. The cubed root of 8 is what? 2, right? So this is going to go out. And then my variables, x to the 5th, I can write it as x to the 3rd x squared, and y to the 3rd. That means that this index matches this power and that power. So one of the x's will go out, one of the y's will go out, an x squared will stay there. Okay? So let's see what's left over. The negative is there. The 8 comes out, it becomes a 2. An x and a y come out, and I have a cubed root of 2x squared. And that's it. And this is day 1. Remember I told you guys, day 1 is going to be the harder test. Because we have all the stuff we did yesterday. This stuff doesn't seem terribly difficult, but the stuff we did yesterday I think is pretty challenging. So day 1, harder test for sure. Okay? Any questions on the first 12 problems? I know you'd have to look back at yesterday's notes, but anything you want me to kind of discuss before we move forward to day 2? Or Friday's test? Because this is all for Thursday's test. Okay. So, Friday's test, when you come in, you'll see questions like this. 4 radical 3 plus 5 radical 3. Now, if you guys remember, if the radicals match, just treat them like terms. So 4 plus 5 is 9. So this is 9 radical 3. And yeah, you can do this on your calculator, but it's probably going to take you longer to type everything in. Okay? The radicals match up. Radical 3, that means they're alike. Just add the numbers in the front and we're good. Okay? Now number 14, it's the same idea, but we have to fix it. We can't just leave it radical 27, radical 8, radical 3. Like, we got to fix it. Okay? So, for 2 radical 27, I'm going to write it as 9 times 3. 8 radical 3, well, I can't really do anything with radical 3. And what can I do with radical 8? Well, the 8 doesn't go out, so what do I break it up into, though? A 4 and a 2, right? A 4 and a 2. If it was a cubed root of 8, then it would come out. Square root, we could break it apart. The 9 comes out, right? The square root of 9 is 3, so 3 times 2 is 6. Radical 3 plus 8. Radical 3 plus this 4 comes out. That becomes a 2, so 5 times 2, that's 10. Radical 2. Can I add anything together? The 8 and the 6, right? Those have radical 3, so that's 14. Radical 3 plus 10 radical 2. And that's going to be my answer. I think we got 2 more examples and then we're done. I think. Let me check. 15, 16, yeah. All right. What's the one main thing that catches my eye that should not be there for number 15? The radical on the bottom. So the way I get rid of it, the process is called rationalization, right? we're going to multiply top and bottom by the denominator. And if there was a 3 here, don't multiply it by 3 radical 2, just radical 2, okay? So radical 2, radical 2. All right, you're going to have to distribute this. So radical 3 times radical 2 is radical 6, plus radical 2 times radical 5 is radical 10, over radical 2 times radical 2 is radical 4. Now, all you got to do is ask yourself, can I simplify anything from here? So radical 6, that's 2 times 3. I can't break that down, so that's going to stay radical 6. The radical 10, that's 2 times 5. Those don't have square roots, so that's going to stay the same. What about radical 4? That becomes a 2. The square root's gone, so there you go. We're done. Okay, that one's finished. So here's our last one. Now for this last one, let me put a little note here. We're going to be working with conjugates. Okay, that means like if the bottom had like an a plus square root of b, you're going to write a minus square root of b. Or if the bottom was an a minus square root of b, you'll put a plus square root of b. You only change the middle term, okay? Don't, if the number in the front is negative, leave it negative. But you're just going to change the middle sign. If it's a plus, you put minus. If it's a minus, you put plus. Okay, those are your conjugates. So I need to fix the radical on the bottom. Now, I did get questions before, like, why is it that I did a conjugate here, but I didn't do a conjugate for this problem, right? You only use conjugates when you have a binomial. That up here, it's a monomial. That radical 2 is just one term, right? But this is 2 terms being added together, so that's why you got to use conjugate. So the conjugate of 2 plus radical 3 is 2 minus radical 3. Now we are going to have to distribute, so we'll get this 2, put it in there, and we'll also do that to the bottom. So let's see, 2 times 2, that's 4, and 2 times negative radical 3 is negative 2 radical 3. Not much I can do with that anymore. And then on the bottom, I have 2 times 2, that's 4. 2 times negative radical 3, that's negative 2 radical 3. And then radical 3 times 2 and radical 3 times negative radical 3. So I'm going to get a positive 2 radical 3 minus radical 9. Now remember, I told you guys, if you did the conjugate right, what's supposed to happen? Yeah, the middle terms cancel out. So gone, gone. Now don't just do that. Make sure, check. Okay, don't just automatically cancel them out, because maybe they don't. That means you did something wrong. But they should cancel out. And then this radical 9 is going to become a 3. So 4 minus 2 radical 3 over 4 minus 3, because that's what square root of 9 is. It's a 3. 4 minus 3 is 1, so basically your answer is this. It'd be that over 1, but we don't have to put it over 1. And I think, let me double check. Yeah, that is the last problem.